let's take a look at this example. Anytime you are going to solve the problems with the diodes, the very first thing which you're supposed to do, you're supposed to look at the polarity of the power supply and the way how the diode is connected to the circuit. So, we're going to use, like always, conventional current flow. So we assume that current flows from the positive terminal of the voltage source to the negative. Okay? Please notice that the anode of the diode is connected to the negative terminal of my power supply, and the cathode, which is basically my negative terminal of the diode, is connected to the positive terminal. Okay? So it means that the diode is in reversed bias. Okay? So it means that the diode is in an open circuit condition. Okay? So it means that it behaves like an open circuit. So when we have open circuit, right, there is no current in this circuit, okay? Because we can redraw this circuit like this. We have resistor, and because the current is going to go in opposite direction, right, to the arrowhead of the diode symbol, okay, because there's like an arrow over here, right? So if my current theoretically is supposed to flow in this way, and I'm going to oppose this arrow, it means that the diode behaves like an open circuit. So I have open circuit. In open circuit, I have no current. That's why I'm going to write that ID, because this is series circuit, ID is equal to also IR, because I have resistor in series of the diode, is equal 0 amps. Okay. Next, the problem is asking me for the voltage across the diode. Okay, so if you are going to measure the voltage across the diode, okay, I'm going to simply connect voltmeter between these 2 points, okay, in order to measure the voltage. And what I'm going to measure, this is open circuit. Open circuit represents basically is recognized by the voltmeter like a very high resistance. And you're supposed to remember from the circuit analysis class that the highest voltage is going to always concentrate across the highest resistance. So this is the highest resistance in my circuit. And according to the Kirchhoff voltage law, the sum of the voltage drops across the resistors, right, across the components in the series circuit, supposed to give me voltage source. So this voltage must be equal my value of the voltage source. Why? Because if current is equal 0, right, voltage across resistor is going to be 0. Okay, we're going to calculate this soon. And this voltage has no other choice to be just negative 9 volts. Okay, so we're supposed to say that VD, okay, is the voltage across the open circuit and is equal negative 9 volts. Okay, next we're supposed to, as I said, find the voltage across resistor. Voltage across resistor is equal the current which goes through the resistor times the resistance of the resistor. Okay, we found that the current which goes through resistor is equal 0 amps times resistance, which is equal 20 ohms. 0 times 20 gives me 0 volts. Now, according to the Kirchhoff voltage law, we have voltage source is equal voltage across the diode plus voltage across the resistor. So voltage source is equal, we found that voltage across the diode is equal negative 9 volts plus 0 volts is equal negative 9 volts. So I have voltage source is equal negative 9 volts, and the sum of the voltages in the series circuit is equal negative 9 volts. So you can say that these are the solutions to my problem. Current is equal to 0, voltage across the diode is equal to negative 9 volts, and voltage across resistor is equal to 0 volts.